So we left off yesterday with the cutting speeds and cutting time calculations. Anybody have any questions off any of those problems out of the packet? Okay, sounds good. So we're going to get moving forward. We started looking at the pieces for those spur gears yesterday. We did the diagrams and we identified what each of those pieces stands for. So today we're going to be looking in the packet. It starts actually on page, the right page here, 247, down at the bottom of that page. There's a table that continues on to the next page with all of the different formulas for finding pieces of those spur gears, or different dimensions from those spur gears. So we're going to look today at how do we find, from certain given information, how do we find missing information using the formulas in that chart. And of course, the first piece that we have to find is we have to figure out which formula to use. So to find the formula to use, first option and best option is going to be our first examples here. Just the formula that is labeled for the value we're trying to find. If we're looking for the addendum, you'll look at the formula that is defined for the addendum. There isn't always a formula that is set up that way, though. Second option is to look for a formula that uses what we are finding to calculate known information. Known values. So if we're looking for the pitch diameter and we know the circular pitch and the number of teeth, there's a formula for that. We just do the division or work our way, multiply it out. The diameter times the teeth gives you the circular pitch. But if we wanted to find the number of teeth and we had the circular pitch and the pitch diameter, we could work backwards. We just put the information in and solve the equation, and we'll look at examples like that as well. Third and last resort is to just calculate what we can from the information we have. And then hopefully that will lead, what we calculate will lead to the answer, what we're looking for. Look at some of those too before we're done, maybe even a little few more of those tomorrow. So anyway, let's look at this first option here. If I give you the pitch equals 10, and I want you to find circular pitch. Now, we had discussed yesterday, looking at those spur gears, remember there's the inner diameter and the outer diameter of the gears. The inner diameter is just the hub, the outer diameter is to the very outside edge of the teeth. When two gears mesh together, their pitch circles, which is somewhere between the inner and outer diameters, those pitch circles touch. So it's the effective size of the gear when it's meshing with another gear. That's the circular pitch. The pitch itself is a ratio. It describes the distance between teeth. The pitch itself is the number of teeth divided by that pitch diameter. Circular pitch is a little bit different than regular pitch. Circular pitch is asking, what is the actual distance from tooth to tooth, from tip of tooth to tip of tooth? So it's the arc around the pitch circle. Basically, it is at the pitch circle from center of one tooth to the center of the next tooth. So it's around the circumference or on the arc of that pitch circle. So if we look up circular pitch and pitch, well, if we go to page 247, we find circular pitch, which is what we're looking for in that table, and it tells us, it gives us two possible formulas for circular pitch. Circular pitch is abbreviated PC. I could have 3.1416. That's just pi. Remember, pi is 3.1415926, blah, blah, blah. That's all that is pi. Times the diameter divided by the number of teeth. Well, here we do not have the diameter or the number of teeth, so that formula does not work. But if we keep looking, the next formula given, there's another formula given for circular pitch, and that is 3.1416 divided by the pitch. That formula will work because we have the pitch of 10 here. So to find our circular pitch, it's pi 3.1416 divided by the pitch, which is 10. So the circular pitch here is 0.31416. That should be in inches, by the way. Pitch would be given as teeth per inch. So when you divide that out, it should give you inches. You might have a formula where we're given more than one piece of information. We might have a formula where we're given pitch diameter. That's just D is what it's labeled as. It's 3.500 inches. The addendum, remember the addendum is that part from the pitch circle to the outer edge of the tooth of 0.1818 inches. And we're asked to find outer diameter, the outside diameter. So we go back and look in our table for outside diameter. Should find that on page 248. And we see for outside diameter there are three formulas. Well, the first formula, DO is the abbreviation for outside diameter. The first formula is the number of teeth plus 2 divided by the pitch. We do not have the number of teeth or the pitch, so that does not help us. The second formula for outside diameter is circular pitch times the number of teeth plus 2 over pi, 3.1416. That doesn't help. We don't have the circular pitch. But if we keep looking down there, the last formula for outside diameter is the pitch diameter plus 2 times the addendum. Makes sense, because remember you have the inside diameter, the outside diameter, that pitch diameter is in between them, The addendum just goes from the pitch diameter out to that outer diameter. So if you do that on both sides, that would give you that outside diameter. So to find our outside diameter here, we're just going to plug that information in. Pitch diameter 3.5000 plus 2 times the addendum, 2 times 0.1818. And we'll just calculate that out. 3.500 isn't going to change. 2 times 0.1818 is 0.3636. And we add that together to get 3.8636 inches. So here, in both of these examples, we looked in the table to find the section of the table for the item we're looking for what we were trying to find the outside diameter. We looked in the table for outside diameter and to find formulas for outside diameter. And in both of these cases, we were able to find a formula that used the information we were given to find the item we were looking for. The second method I discussed was looking in the table to find information we're given to see if we can work backwards for what we're looking for. And this would be an example like say I am told the addendum is 0.2000 inches. And I am told the outside diameter is 4.800 inches, 000 inches. I'm asked to find the pitch diameter. Well, if I look at my table for the pitch diameter is on page 247. For pitch diameter, we're given 2 formulas. The first formula for the pitch diameter is N over P, number of teeth over pitch. Don't have the number of teeth or the pitch. Second formula for pitch diameter is the number of teeth times the circular pitch divided by pi, 3.1416. We don't have the circular pitch either, so neither of these formulas are going to help us find what we're looking for. So all of the formulas listed for pitch diameter, neither of those formulas use the information we were given, the addendum and the outside diameter. So the second strategy, since the simple strategy didn't work here, is to look for a formula for one of the things we're given. So we look for a formula that defines let's look for the addendum first. If we look for the addendum has 2 formulas given for it. One is, if I can find it here, little a is the addendum. It's 1 over the pitch, 1 over P. Now there's an asterisk by that. Some of these formulas are only good for a certain style of gear. I believe it's, what is their degree? 14.5 degree? Yeah. 14.5 degree convolute gear. So the 14.5 degree defines the taper of the teeth of the gear. The gears, there are square tooth gears and there are convolute gears. Convolute gears have a tapered tooth. So this formula only applies if we have that certain type of tooth on our gear. Which it doesn't matter. In this case, we are not given the pitch here anyway. We're looking for the pitch diameter. So that formula doesn't help us either way. And the other formula for the addendum is 0.3183 times the circular pitch. Again, we're not looking for the circular pitch either. That formula doesn't help us. So let's go over to formulas for the outside diameter here. Look at formulas for the outside diameter. We have n plus 2 over p. Again, we don't have the number of teeth, and we're not looking for the pitch. That doesn't help us. We have circular pitch times m plus 2 over pi. That one doesn't help us. We don't have the circular pitch, and we're not looking for it. We don't have the number of teeth either. We do have outside diameter is equal to the pitch diameter, d, plus 2 times the addendum. This is the formula I actually used in the last problem. We're given the outside diameter, and we are given the addendum. So we can work backwards to find the pitch diameter here. So we put in the information we have. The outside diameter is 4.8000. We're looking for the pitch diameter. So plus 2 times we're given the addendum is 0.2000. And now we solve this. So first we have to combine what we can on either side. So 2 times 0.2000 is 0.4000. Everything else stays exactly the same. Now we need to subtract the 0.4000. Give us 4.4000 equals the pitch diameter. So there's a case where we had to look through the formulas for the items we were given and see if we can use those formulas to work backwards to what it was we were trying to find. Let's do one more example of that. So here we are given outside diameter 4.3750 and a circular pitch of 0.3927. And we're asked to find the number of teeth. First number of teeth is just big N, right? So again, we look in the chart for number of teeth. That's always our best option. I don't think there's even a, well, there is. In the very bottom, there is a formula. The last entry in the table, there's 2 formulas for number of teeth. Number of teeth can equal pitch times pitch diameter. Well, we don't have the pitch or the pitch diameter. And we have number of teeth equals pi, 3.1416, times the pitch diameter divided by the circular pitch. We have the circular pitch, but we don't have the pitch diameter. We have the outer diameter, outside diameter here. So we need to go look at the other items and see if we can work backwards to this. If we look at circular pitch, that's back on the previous page. Circular pitch has 2 entries, 2 formulas. Pi, 3.1416 times diameter over n. We have n, or we're looking for n, the number of teeth, but we don't have the pitch diameter. We have the outer diameter. That won't work. Circular pitch could also just be 3.1416 over the pitch. We don't have the regular pitch. We're not looking for the regular pitch. So that's not going to work. Look at formulas for the outside diameter. We've done this a couple times here. I am going to look down the second formula rather than writing them all out. The second formula for outside diameter is the circular pitch times n plus 2 over pi, 3.1416. Here, we have the outside diameter. We have the circular pitch. We're looking for the number of teeth. So that formula has all of the items in it that we're given and or that we're looking for, and nothing that we don't have, nothing that we're not given. So we can use that formula to work backwards to find the number of teeth. I put in my outside diameter, 4.3750 equals. Put in my circular pitch, 0.3927 times n plus 2 over 3.1416. Now, there's a lot of ways we can approach solving this problem. They're all going to force us to round off our calculation. Dealing with spur gears, you can see that consistently they've been rounding to 4 decimal places, and that is generally what we would go to. First thing we would do here is I would distribute 0.3927 times n is 0.3927n. 0.3927 times 2 is 0.7854, and that is still over 3.1416. And it still equals our outside diameter of 4.3750. Now that we've distributed, there's nothing to combine on the right side anymore. Technically, you could distribute dividing by the 3.1416. But it's way simpler to just multiply by it and get rid of it, times 3.1416 on both sides. So it's gone on the right side, leaving us just 0.3927n plus 0.7854. On the left side, 4.3750 times 3.1416 gives us 13.7445. Now to solve this, to finish solving this, we have to subtract the 0.7854. So that 13.7445 minus 0.7854, 12.9591 equals 0.3927n. Of course, the last thing we have to do is to get rid of the 0.3927. It's multiplying n, so we're going to divide by it. One thing to remember here, n stands for the number of teeth. You can't have half a tooth. So when we divide here, this better come out to a number, and I'm putting myself out on a limb here because if this doesn't work out, I'm going to look stupid here. This better come out to a really close to a whole number of teeth. It won't be exact because there's rounded numbers, but it better come out pretty close to a whole number so that we're comfortable rounding it off to the nearest tooth. Here it actually did come out exact to 33 teeth. So 33 equals n, so that gear has exactly 33 teeth. We talked a lot in the fall semester about estimating before you calculate, and we did it with whole numbers and percents and the benchmarks with percents and all of that. Same thing applies here, not necessarily estimating. These numbers, 4 decimal places, it's tough to really estimate. But by knowing what the number stands for, in this case, number of teeth, knowing that it has to be a whole number, it does allow us to do a little bit of estimating to double check to make sure if our calculation doesn't give us a whole number of teeth, we know we screwed something up. Now, the third option is the most complex option, where the information we're given does not lead us to what we're trying to find. But we can take the information given, find something else, and then that can be used to find what we are looking for. For example, if we are given the number of teeth, 10, and the pitch diameter is 3.6667 inches, and we are asked to find the hole depth. So this is the depth of the tooth. Remember, there's two depths on a tooth. Boy, my artistic abilities, it's amazing how much they grow from day to day. So there's our gear. Pretend that looks like a gear. The hole depth is from the outside of the tooth all the way in. It's the outside diameter to the inside diameter. So it's that difference in the radius of that outside radius to the inside radius. The working depth is from the gear that works next to it. The working depth is the distance that the tooth from the next gear penetrates between the teeth of that gear. So it doesn't go all the way into the inner diameter. So we are looking for the hole depth here. So we look in our formulas for hole depth. Find hole depth, which is abbreviated, of course, WD. Hole depth has two formulas given. 2.00 divided by the pitch. Well, we don't have the pitch. Or hole depth could be defined as 0.6366 times the circular pitch. Again, don't have the circular pitch. Neither of those formulas is going to be very helpful to us here. But we're not going to totally ignore them. I'm crossing them off for now, but we may come back to them. If we look at the formulas for number of teeth, we have two formulas for number of teeth. Number of teeth equals pitch times diameter. That doesn't include the hole depth. Or number of teeth equals pi times diameter divided by the circular pitch. Again, that does not include the hole depth. So we can't find the hole depth from the number of teeth. If we look at pitch diameter, that's the last one on page 247 down there. Again, those formulas for pitch diameters involve the number of teeth, but then they involve the pitch or the circular pitch. We don't know either of those. And not only that, but we're looking for the hole depth. The hole depth is not in either of those formulas. So right now, we cannot find the hole depth directly from either of the pieces of information given here. So let's look at what can we calculate from what's given. Well, number of teeth and diameter, or pitch diameter, is the definition of pitch. So I look there, I can find the pitch. Pitch is equal to the number of teeth divided by the pitch diameter. So that's 10 divided by 3.6667. 10 divided by 3.6667 gives us that 2.7272. That's rounded correctly. It is. That is the pitch. Well, if I know the pitch, now I can come back here to working depth. This first formula for working depth was 2.000 divided by the pitch, or the hole depth, I should say. So the hole depth, 2.000 divided by that pitch of 2.7272. So on my calculator, divide that out, 0.7333. Inches is my hole depth. So that's saying that's how basically how big the tooth is there. Those are a little trickier because we're not really sure what to look for in the table. We have this information, and we look through the table to find whatever we can calculate from that information, and hopefully that new piece, once we've calculated it, gets us to what we're looking for. So it's a matter of being patient with these. The packet does divide the problems up by that, the first table of problems. You can just look up the formula, calculate it out. The second table of problems, you have to look up the formula for one of the givens and work backwards. And then the third table, you've got to go through these two steps here. So for right now, out of that packet, page 251 through 252, I'm going to have you working on 1 through 53, the odds. Tomorrow, we will finish up all the spur gear stuff. We'll actually look at metric modules. That is the metric equivalent of pitch for dealing with gears and the distance between teeth and all that. And that'll be it. We'll finish that up tomorrow. And then, of course, Thursday is our Unit 2 test. So then we'll be able, our next step then is to start getting into the trig. Anybody have any questions? Okay, well, I'll let you have the rest of the time here. We got 17 minutes left to start on homework. I'll be on the network here if you have any questions. Otherwise,